going to start off with the drill press. All right. Drill press is probably one of the most commonly used shop machines. Who has not used a drill press before? Everybody's used it before. Great. So all this should be a refresher. Okay. I'm going to talk about how we do it, what speeds we should use, things that we do, things that we don't do, and things that if you do, you're going to live in infamy. All right. So to start off with, the drill press has a chuck. All right. This is commonly referred to as a Jacobs chuck. All right. And that was one of the primary manufacturers of the chuck. This chuck is not actually a Jacobs chuck, but it's a Jacobs style chuck. And so it utilizes a chuck key that basically fits into the little holes here, and then we've got our little gear set that engages and allows us to close up the jaws. Okay, so there's 3 jaws in here that grasp our drill. I'm going to set my drill up in there, and then just by hand I'm going to tighten this up. All right, now it is possible. All right, looks like it's in there, right? All right, no? Why not? Okay, the smaller the drill, the more likely you are to do that. All right, and it will happen to anybody. I've done it many, many times. I think I've got it. All right, so before you get all excited about drilling a hole, put everything in there, turn it on, and look at the run out of the drill. All right, what do I mean by run out? This is a fairly cheap drill, so it probably has some fairly significant run out. Let me zoom in. All right, everybody come over and take a look at it. So if you look at the back of my hand, you can see that the tip of the drill is doing this. All right. Everybody, so if you've seen, walk around, everybody else come up. Okay. So the less expensive drills, very common to have run out. All right. What does that mean? If I'm drilling with this, what does that mean? You got to speak loudly, guys. I'm deaf in this ear. I don't hear well out of this ear.
It's got less precision. It'll be bigger than what
yes.
it is.
Right. So when I went and got this drill, right, I got it because that's the size that I wanted my hole to be. All right. And because this is a low quality drill, all right, when I drill that hole, it's actually going to be bigger than what the actual outside diameter of this drill is. All right. And so that's something I need to keep in mind. All right. Drills are not precision instruments anyhow. Even if I get a really high quality drill, all right, it's still going to be 1 or 2 thousandths or more larger than what the diameter of the drill is. All right, because drills just really are not precision instruments. Okay. We also have run out in the chuck. Okay, this is a Grizzly, which is a decent quality, but you know, if I were to actually put an indicator on the chuck on this, it wouldn't surprise me if it already had 1 thousandths or 2 thousandths of run out in it. All right, which means that whenever I drill a hole, it's going to be bigger than what I'm drilling the hole with. Okay, so something to think about. All right, so again, use your hand to get that up in there, and then tighten it up. How tight? All right, I don't need to be a gorilla with it. I just need to snug it up. Okay, smaller drills, now, yeah, just snug it up. All right, it doesn't need to be super tight. All right, once you do that, turn it on. Yeah, okay, everything seems to be running okay. All right. Now, with this actual machine, I have the ability to raise and lower the table. Why would I want to do that?
For a larger piece.
Right. So let's say that, for whatever reason, I wanted to drill a hole in this. All right. Well, it's a little difficult to do right now, so I can lower my table. All right, until I get to the point where I can get a drill over the top of it. Okay. Let's talk about the table. So the table is set up, it has a hole in the middle. All right. And you notice that I have this thing on top, and it has a whole lot of what? got a whole lot of holes in it, right? If we look at the tabletop, it doesn't have any holes in it other than the one that was cast in it initially. All right? If you put a hole in my tabletop, your name is going to be put on that forever. And I'm going to talk about the person who put the idiot mark in there. Not that I'm calling you an idiot, but you did put an idiot mark in there. Y'all get what I'm saying? All right? So, whenever you're drilling, know what you're drilling into, all right? And if you're going all the way through, make sure that you have something underneath it so that you're not putting an idiot mark in the table. Because I will write your name on it. I promise you I will. All right, so what are other things that we have on here? It does have a light, all right, which is handy. All right, what else does it have? Well, we have what's called a quill stop, all right, which is set right now. So we've got 2 nuts here on this, and I can adjust that. Why would I want to have a quill stop?
So you don't put an idiot mark in the table.
What's that?
So you don't put an idiot mark in the table.
Okay, that's one reason.
Set the depth of the hole.
Right. So let's say that I'm drilling a series of holes, right? And I want them all to be the same depth. All right? Once I get this, I can set my depth, all right? And then when I drill each of those holes, they're all going to be the same depth within 10 or 15 thousandths. There will be some variability. All right? Work holding. How do I hold work in the drill press? There's a lot of different ways that I can hold work, right? If I'm drilling on something that's long, give me that. So if I'm drilling something that's long, all right, I can be fairly comfortable holding this in my hand, right? It's got a lot of mass to it, all right? There's no real sharp edges on it, and so I actually could hold this and drill it, and I wouldn't feel uncomfortable about it, all right? If this were thin, had a thin cross-sectional area, all right, I'd be much more concerned about it, all right? What happens is that as our drill is drilling, all right, typically when I start, it jumps around a little bit, all right, you're going to see that, and we're going to talk about some things that we can do to minimize that. And then as I get the hole started and I'm drilling, really there's not much of a problem. I can hold it and it lulls you into a false sense of security, all right? Where's the problem occur? Who's used a drill press before and have had bad things happen? Mariah, what happens?
The drill bit broke because, or it got stuck in a piece and then spun the whole thing around.
Yep, that can happen. Happens a lot, actually. So you're drilling a hole, especially if you're drilling a deeper hole, all right? So as we're drilling, the material is heating up, the drill is heating up, all right? And we've got little pieces of chips of the material that are building up in the hole, and it's real easy for it all of a sudden to seize up, and your part wants to swing around, all right? Well, with this, again, this is wood even, so wood I'm probably going to be able to stop without any real issues to begin with, all right? But if this were steel, all right, it's possible that it might catch in here, it might swell up and want to start swinging this, all right? But I've got a lot of leverage with this, all right? Again, I wouldn't be overly concerned about drilling this without putting it in a vise, all right? If it were this long, it's going in the vise. I can't hold that and drill it, all right? Not safely. All right? So it catches, it swings, all right? So it can swing around and bite you. You can break the drill. In ENP370, I think it was you guys' class, wasn't it? We had somebody that got the drill bit caught and it broke. And was it your class or not?
I think so.
Yeah, I don't remember who it was.
It wasn't any of them.
I think it was the other Noah, I think, wasn't it?
No, very
I think it was. But anyhow, that's exactly what happened, is that they were drilling, the workpiece heated up, the drill heated up, and it bound, and it slung, and it caught, and it wound up, and it was actually a fairly substantial drill bit, all right? Scared the person who was doing it. All right. So take steps to avoid that. All right. So when we're drilling, we're going to clear our chips frequently. All right, which means I drill a little bit and then I let it up. All right. And what that does is it clears the chips out of the hole. And as I'm drilling, and I'll drill something here in a minute. As I'm drilling, you'll see chips form and they'll spiral up. Right. Well, we don't want those spirals to get very long because what they are little razor blades. All right. And so it's not terrible on a drill press, but when we get into the lathe, all right, those chips can actually build up quite long. All right. And so what happens is we got a chuck spinning and those chips catch and it'll cut you. It'll cut you to the bone. All right. All right. So other work holding. We can use the vise. All right. And so I put it in the vise and then I'm going to hold on to the vise. All right. We'll also notice that as of right now, the vise does not have any idiot marks in it either. So what does that tell you?
You put one inside the vise underneath that.
Right. So over here I keep little pieces of wood, all right? All right, and we can cut more. All right, put a piece of wood underneath. The vise does actually have an area that's clear in the middle, so drill through the middle of it. All right. And so basically just think about what you're doing. All right, when you're going to drill something, where does it go? Where's the drill going to wind up when it's all said and done? What if I overshoot and I drill through it when I didn't mean to? Do I have something to stop it from drilling into the vise with the table? All right. If you look at the table behind you, that came out of a high school wood shop, and you see that it's got holes everywhere. All right. And it's because people will just drill through something right into the table. Okay. So whenever you're doing something in this shop, I want you to think about, if I were doing this on my mom's dining room table, all right, would she be happy with the end result? All right. And if the answer is no, then you're doing something wrong. Okay. All right. So I also can use a clamp to hold my piece of work. So somebody hold on to that, please. Get out of there. All right, so I can use the clamp to hold my piece of work. All right, I can make minor adjustments by moving the table left to right. All right. But good idea, if you're doing something that you can't hold in the vise, go ahead and clamp it. All right, if you're cutting sheet metal, if you're drilling sheet metal, all right, you absolutely must clamp it. Absolutely. And use a couple of clamps. All right. When I was in high school shop, I was trying to drill a piece of sheet metal, all right, and it caught, and it literally laid my hand open to the bone. Okay, it was bad. All right, I've never done that again. That was enough. All right. If you do something and you hurt yourself, okay, please, please, please immediately let me know. Even if it's something minor like a minor cut, okay? If you're working with your hands, you're going to cut yourself, all right? It's just a given, all right? As you get older, you get better at it, but you still cut yourself from time to time because the things that we do are sharp, all right? And so you're going to miscalculate and you will cut yourself. When you do that, let me know. All right? If it's something minor, we'll put a Band-Aid on it and we'll move on. If it's a little more serious, I'm going to document it just to say that, hey, this occurred, and that's for your sake as well as mine, so that if you have complications with it, you can come back and say, hey, I did this while I was in class, and so Taylor has a little bit of responsibility for helping me get through this. All right? All right, what questions do we have about the drill press? Yes?
Can you drill at an angle somehow?
On a drill press, you can, but you have to do it, set it up in the drill press or your work holding to do that. All right, so not very common that you do that in a drill press. If I'm going to drill something on an angle, I'm going to set it up in the milling machine. So what speed do we use?
Depends on the material.
Depends on the material, and it also depends on what I'm drilling with. Yes. All right. So there are a whole bunch of different cutting speed formulas. All right. And back in high school and even when I was going through my undergrad, you know, I had those memorized. I don't use those anymore, all right? What I do tell you is that the larger the drill, the slower the speed, all right? And to listen when you're trying to drill it, all right? If it's going, all right, you're going too fast. If it's making all kinds of squeaky sounds, you're probably going too fast, or you have a very dull drill bit. All right. Another thing to think about is that you can actually feel what's going on as you're drilling. All right. And so it's hard to explain that, but as I'm drilling, I know what's going on. I can feel it feeding in. I can feel the chips cutting, and if I hit a hard spot, I can feel it. All right. So if you come up and you're just like, that's not what we're supposed to be doing, okay? Let the tool do the work. When I'm drilling something, I really shouldn't be putting more than 3 to 4 pounds of pressure on this to get it to go. Right? So how do I change speeds? So up here we have a pulley arrangement, right? And if you look up on this, there are 12 different speeds that I can do. Right. So what I'm going to do is I'm going to loosen this and I'm going to pull the motor in close to the machine. All right. And what that does is it loosens up the belt somewhat. It doesn't loosen it up a whole lot. And then I'm going to adjust the belt to represent what I want. Right. So everybody here is an engineer, and so you know that if I have a small pulley feeding a big pulley, what does that do to the speed? Small pulley driving a big pulley, what does that do to the speed? Slows it down. All right. And so typically this is set up to run drill bits of about this size, around 1/4 inch. All right. In aluminum and steel and even wood. All right. So turn it on, look at the speed. If it's really cranking, right, you probably need to slow it down. Somebody else moved it and adjusted the speeds. All right, so let me find something to drill. Go ahead and pause it. That's where I want my hole to be. If I just set this up in a drill press and I start to drill that hole, all right, what are the odds that I can get that to start right where I want it? Not very good, right? And so what I'm going to do is I'm going to take, basically this is an automatic center punch, and I'm going to lay it right in the center where I want it. All right, and now I have a little divot. Okay, so that gives me a starting place for my drill. So I want to wind up with a drill that's the hole that's this big. It's a 1/2 inch drill. All right. Now I could just go, yep, okay, and drill that through there. All right. What's the problem with doing that?
Not a lot of walkout.
It's going to be, yes, it's probably going to walk a little bit. It's going to want to walk as it starts because we've got a fairly large tip, all right, that's trying to find this little bitty hole, all right? And so we're going to use a process called step drilling, all right? So the very first thing that I'm going to do is I'm actually going to use what's called a center drill. Some people also use just a short length jobber drill, all right? And basically what that does is it's very short and it's very stiff, and so it doesn't walk. I mean, you can make it walk, but it's very difficult to do, all right? And I'm going to find that center, and I'm going to drill this down until I start to get a little cone shape. All right, so I'll have the center of it buried, and then I'll start to get a little cone shape, and that gives me a really good starting place. Then what I'm going to do is I'm going to start with a fairly small drill. I'm going to drill that through, and then I'll step it out. All right, and then I really, if I were going to do, it wouldn't hurt to have another size in between, all right, but this will work. All right, questions? All right, let's do it. Have enough right, so I've got it. And what I'm going to do is I'm just going to get it down close. I'm going to kind of jiggle the work around until I get it close. Did everybody see what just happened? What happened?
Device started shaking.
What's that?
Device started shaking.
Okay. And so what happened is I wasn't exactly on that little divot that I put in there. And so by just lightly holding the vise, it self-aligned. And so then it was right on time, right on spot, and it went. All right, again, you saw that, it jiggled around. And again, I was just lightly holding the vise. All right. All right, there we go. So now we got a starting place. And that is right where I want it. Did you hit? Yeah, thank you. All right, so as we're drilling, we see that we've got this chip formation, right? All right, this is really dangerous because it's a little razor blade rolling around here. So how do I stop that? If I just lift up, if I'm drilling, oops, and I lift up, it'll break that chip. All right, now everybody see what happened? What happened? Because I was busy talking instead of paying attention to what I'm doing, it actually climbed through and was going up. All right, and if I'd have just let it go, what would have happened? It would have spun around, and ultimately it would have broke the drill, and it would have thrown the chuck out across the room. All right, so lesson to be learned. When you're doing this, pay attention to what you're doing. All right, don't be trying to talk to people and do this at the same time, because if you, and again, this is a really small drill. It shouldn't have done that, but it did. All right, so there's one. No, I'm going to start calling you Vanna. You probably don't know who Vanna is, do you?
I do.
Okay.
I'm not happy about it.
All right, so again, we got a little bit of vibration as it's trying to find itself, it's trying to find its center. And again, I'm just lightly holding the vise so that it can self-center and find itself. All right, so I put down a little bit and then I let it up. All right. The point of danger when you're drilling is as it's breaking through the back side, because what happens is as it starts to break through, it wants to grab. All right, and so that's really where you get into trouble, is it grabs and then it wants to have a very, very violent action. All right, Noah, final drill bit. All right, and this may be a little bit too fast for this one. We'll find out. All right, so I've gone to a larger drill, so I'm going to drop my table down a little bit. All right, so now as this one tries to, it's going to chatter. It's going to chatter a lot. All right, hear that sound? What's that telling me? It's a little too fast. Now, I can overcome that by increasing my feed just a little bit. All right, there we got my chips. If it does that, bring it out, stop it. All right, and clear your chips. And you really shouldn't use your fingers. Aluminum's not too bad, but if that were steel, there's no way I'd do it. All right, so again, I can overcome by increasing my feed, but as I get close to the bottom, it may be problematic for me. Okay? Questions? All right. Final thing on the drill press. When you're done, clean it up. Where does this go?
On the table?
No?
Oh, in, yeah.
Okay, put it in there. I never have to look for it. It's right there. All right. So there we have it. We got a hole drilled through. There's no holes in my vise. Tell me what you feel on that. It's warm, right? When we're cutting metal, we're creating heat. We're creating friction. Friction. We're creating friction. Wow. We're creating friction. All right, I'm going to go ahead and pause that one. All right. Advantages to using a bandsaw versus, say, a milling machine is that I can remove a whole lot of metal very quickly with a bandsaw, and I'm not burning up an end mill. Okay? Because end mills are expensive, they have a finite lifetime. All right. And so if I were going to, hand me that piece of wood over there again, please. Or actually, never mind, I can use this. So let's say that I were going to mill out a pocket. I was going to cut out a pocket of this, all right? We'll say this is steel or aluminum or whatever, it doesn't matter, unobtainium. All right. If I were going to do this with a milling machine, I could, and I could do it very accurately, right? All right. But I've got to cut all this material, chip by chip, tooth by tooth is going to be removed. With a bandsaw, I just go in and I'm going to cut the periphery of it, and it's gone. All right. So rapid stock removal, if I have to move a lot of material, this is probably the quickest way to go and the easiest way to go, and it saves on tool life. All right. So bandsaws have different blades for different materials. All right. So this one is actually set up for aluminum. All right. So if you come over and you try to cut steel on this, it's not going to cut very well, and you're going to destroy the blade on this, and so then we're going to be replacing the blade, all right, and probably your part too, because it's not going to do very well. All right, so what do? So we have, this is a release back here, all right, that releases this little tram. And what it does is it's got a set of bearings here that ride on each side of the blade, all right, to keep the blade going where it's supposed to go. When I'm setting this up, what I want to do is I want to have just enough clearance for the part that I'm cutting to fit underneath these. All right, and so I'm just going to roll it down. That's probably good. And then I'll tighten this up. And what that does is, instead of having this much blade out there that can flex and bend and do all kinds of stuff, I now have this much blade. All right, so it helps the saw. All right, once I do that, if I'm going to try to do a straight cut, okay, we do have a fence on this. My experience with using fences on bandsaws is they don't work real well. All right, because what happens is the blade will start to cut on one side heavier than the other, and then the blade actually will start to kink a little bit. All right, which then causes your work to twist, even though it's up tight against this, and so it doesn't work real well. You can make it work real well, but you have to take your time, and literally, I mean, you're not feeding this in at all, you're just letting the bandsaw cut, and then you're feeding just a little bit at a time, okay? It can work, but not real well. I would not consider this a precision machine. Right? So, over here we have the start and the stop buttons. We have a button that says on off. Right now it's off. Now it's on. And start. Over here I have a little rheostat that controls how fast the blade is traveling. All right, so most of the things that we're going to be doing, 700 to 800 RPM is probably plenty fine. All right. When I'm cutting this, all right, the blade likes fingers, so don't feed it. All right, so I want to keep my fingers away from the blade. All right, and so when I'm pushing this through, you'll notice that I'm grabbing on the outside of it. All right, now I've got my thumbs here on the back of it, but they're not anywhere near where the blade is. And then I'm just going to feed it through. blade's a little dull. It should have went through that like hot butter. All right? So I could have speeded it up a little bit. All right, might have helped, but the blade is getting a little dull. All right? Things not to do. All right? If it's making funny noises as you're trying to cut something, stop what you're doing and come and get me. All right? Do not try to force it. All right? If you try to force it, what you're going to wind up doing is you're going to wind up jamming the blade in your material. The blade is going to break. All right? And what can happen is that as the blade breaks, it can whip out and it will actually bite you. All right? That does happen. If I'm going to cut something, it's not a bad idea to use another board or something behind it. So that way, as I cut through, I don't have to worry about my fingers because I got a whole lot of room in between my fingers and the blade. All right? Do not try to cut super small stuff on this. All right? If you've got something that's really short, don't try to cut it in this. It's not going to work out well for you. All right? I can use the drill press vise over here to cut things. All right, to hold it, push it through. All right, it's not a bad way to go. All right, questions on this? Yes, sir.
What are the different tooth sizes for different materials? Like, how do you tell the difference if it's set up for aluminum or?
That's a really good question. So we'll talk about TPI. It's called threads per inch or teeth per inch in this case. All right. So the more teeth there are per inch, the harder the material that you're going to be cutting. All right, so if you look at it, and like this has got, I don't know, this is probably like a 12 or 14 tooth per inch. All right, and so it's a mid-range. It's good for aluminum. It's good for wood. Not good for steel. All right, because we've got fairly aggressive teeth. All right. Now, could I cut steel on it? Probably, but that really would destroy the blade. All right. So if you look at it, and you can count, you can just take a ruler and put an inch and count the number of teeth, right, and that'll tell you what the TPI is, the tooth per inch. Right? And so if we're cutting into steel, you know, we probably want something around a 20 tooth per inch, right? So it'd be almost double the number of teeth of what this has. So good question. All right, what other questions we have? Yes, sir.
If we wanted to change out the blade for a different setup, would we be able to do that, or how do you do that?
I don't have another blade for this
Okay.
right now, so no. Yes, sir.
You said not to use this with really small pieces, so what would you use to cut this piece?
Like literally, if it's under an inch in length, all right, you just can't get close enough to it to actually do it without being in the danger zone. I mean, use common sense. I mean, really. As long as you're using common sense, this is really a very safe tool. But you know, when you're trying to make do with something and you're trying to do something and you got that little tingly feeling in your gut saying, I don't know about this, don't do it. Because I really don't want to take somebody to the emergency room and have your thumb sewed back on. To date, I haven't had a serious injury in the 5 years that I've been here. Don't be the first.
So in the case of small pieces, you would use the mill or something else?
Yeah, for small pieces, hacksaw. Okay, you got a lot more control, and you're not going to harm yourself. You might slip and cut yourself, but you're not going to cut a finger off with a hacksaw. All right, anything else? All right.